So, today we're diving into a technology that's quietly changing the game for artificial intelligence. It's happening right on the phone in your pocket, making it smarter while keeping your personal data, well, personal. Let's dig into how it all works.
I mean, really think about it for a second. How does your keyboard get so good at predicting the next word you're going to type? Or how does your photo app recognize your friends' faces? How does it learn all this without, secretly reading all your texts and looking at all your pictures? That's the huge puzzle we're going to solve today.
And that question, it leads us right to this fundamental conflict in all of modern tech. I'm talking about the data privacy paradox. On one hand, we want these incredible, personalized AI features. But on the other, the traditional way to build them meant companies needed our data. And of course, we want to keep that data private. It's a real tug of war.
The amount of data we're talking about is it's mind-boggling. Every single tap on your screen, every message you send, every step you take with your watch, it's all a data point. This stuff is basically the fuel that powers machine learning. But gathering it all in one central place, that's a massive privacy nightmare waiting to happen. So what's the fix?
Well, the solution required flipping the entire model on its head. The old way was simple: send all of our sensitive data to the AI code sitting on some company's server. But the new way, it sends the AI code to our data right on our own devices. Our data never has to leave home. And that simple switch, it changes everything.
This new way of thinking, this whole new approach, yeah, it's got a name. And it really is a completely new paradigm for how we can teach our machines.
It's called Federated Learning. And at its heart, it's a distributed approach. The AI model training doesn't happen on a big central server. It happens on a whole network of decentralized devices, like your phone. Your raw data, your messages, your photos, it stays put, safe and sound. Honestly, this quote right here is the mantra for the entire field. It just perfectly sums up the revolution. By bringing the code to the data, we can finally start to solve those massive problems of privacy, of data ownership, and even just the logistical nightmare of moving huge amounts of data around the internet.
Okay, so how does this actually play out in the real world? Well, you can think of it like this carefully choreographed dance between millions of individual devices and one central server. It isn't chaos, it's a superstructured protocol.
Let's break that dance down into what's called a single learning round. First up, selection. A server picks a small sample of devices that are ready to go. Second, configuration. That server then sends the current version of the AI model down to each of them. And third, the most important step, reporting. Each phone uses its own local data to train that model and then sends only a tiny, anonymous summary of the changes, not the data itself, back to the server. The server then averages all those little updates together to make the main model just a little bit smarter. And then the whole cycle starts over again thousands of times.
So you're probably wondering, when is my phone doing all this extra work? Well, the whole system is designed to be totally invisible to you. Your device only becomes eligible for that dance if it's idle, plugged in and charging, and connected to Wi-Fi. That way it never kills your battery or burns through your mobile data plan.
Okay, this is all really cool from a tech perspective, but what does it actually mean for you and me? Why should we care? Well, it means we can finally have the best of both worlds, really smart apps powered by cutting-edge AI, without having to give up our privacy to get them.
And hey, this isn't some pie-in-the-sky theory. This is happening right now, across a ton of different fields. It's on our smartphones, powering things like next word prediction. It's used in healthcare, letting different hospitals collaborate on medical research without ever sharing confidential patient files. And it's even in the Internet of Things, helping self-driving cars learn from each other's experiences on the road. For a perfect everyday example, you don't have to look any further than the keyboard on your phone. Google's Gboard uses this exact system to make its search suggestions better and better, all without your actual search queries or typed words ever having to leave your device.
And we're not talking about simple, dinky little models either. You can think of parameters as all the little knobs and dials that an AI can turn to make its decisions. The model for Gboard's word prediction has about 1.4 million of them. That just goes to show you that federated learning can handle incredibly complex, massive AI tasks, training across millions of phones in just a matter of days.
But as you'd expect with any technology this revolutionary, it's not all smooth sailing. Trying to actually implement this in the messy real world, across millions of different devices you don't control, well, that comes with some pretty significant challenges.
This graph right here shows one of the biggest headaches. See how the line goes up and down in a regular pattern? That's showing what's called diurnal oscillation. It's a fancy way of saying that way more people have their phones plugged in and idle at night while they're sleeping.
This simple, natural 24-hour cycle has huge implications for when and how the AI model can actually get trained.
And that reality leads to some real hurdles. First, you've got availability bias. If the model's mostly learning from data when people are asleep, does that change what it learns? Second, the network is just unreliable. In any given training round, something like 6 to 10% of devices just drop out before they can finish. And finally, there are hardware limitations. This stuff works best on newer phones with fast Wi-Fi, which could create a model that's biased towards data from people with more expensive devices.
So where is all this headed? Well, the top researchers are already looking beyond just machine learning. They're asking, what if we could apply this privacy-first, decentralized model to all kinds of different calculations? The future might not just be about federated learning, but about a much bigger idea: federated computation. Imagine a world where all of our devices can work together to solve huge, complex problems, all without any one of us ever having to compromise our own privacy.